Traditional intersections are places where vehicles, pedestrians, and bicyclists cross paths. This presents many opportunities for severe crashes. The good news is there are intersection designs that are safer for everyone. Some of these safer intersections look very different. Others may look familiar, but require a different way to make left turns. The goal is to either reduce the chances for serious crashes or manage the circumstances around crashes to make them less severe. Whether an intersection crash is severe depends on three factors: conflict points, vehicle speed, and collision angle. Intersection conflict points are where the paths of different intersection movements merge, diverge, or cross. They can involve vehicles with other vehicles, vehicles with pedestrians, or vehicles with bicyclists. Where there is a conflict point, there is the potential for a collision between users. For instance, here are the conflict points of a standard intersection. All conflict points have the potential for harm, but left turn conflicts are especially serious. Of the 32 vehicle-to-vehicle conflict points at a conventional intersection, 12 are associated with vehicles turning left. Now, consider a couple different intersection design options. If it were a reduced left turn conflict intersection, vehicle-to-vehicle conflict points are cut in half. If it were a roundabout, vehicle-to-vehicle conflict points decrease from 32 to 8, including the elimination of all left turning and crossing conflicts. Other intersection designs are also effective at reducing or modifying conflict points, and all improve or maintain traffic flow while making the intersection safer. Next is vehicle speed. As speed increases, the amount of energy that can be transferred in a collision increases exponentially, creating a higher likelihood for severe crashes. Intersection designs that effectively slow vehicles through conflict point areas are relatively safer. Collision angle also influences crash severity. This diagram represents the relative degree of harm in a vehicle-to-vehicle crash at different angles. Traditional intersections present multiple opportunities for vehicles to collide at more dangerous angles, especially during left turns. Intersection designs that change the angles at which vehicles move through reduce the chances of severe crashes. Equipped with knowledge about conflict points, vehicle speed, and collision angle, roadway designers can devise fundamentally safer intersections for people driving, walking, and bicycling. The roadways, including intersections, are for everyone. So, if you see a new or different intersection design in your area, you can know that your community just got safer.
Good evening again. This is Gachimo Ithaka from Roads Up speaking. It's wonderful and it's an honor to have you guys with us tonight. We appreciate you guys sacrificing the time to be here with us. So as we look forward to starting the learning session on intersection design, I know a lot of guys have been with us. A lot of guys have asked for these sessions through LinkedIn, and we are happy to host a session on intersection design. This will be a part one of a series that we are going to be introducing. So once we do this one session today, stay open or stay curious per se, and also stay on the lookout for more from our series. So the numbers are steadily rising, and I don't want to leave anybody out. So as usual, I'll replay the video. Then we are going to have a short interactive session as we wait for Engineer James to join us. So this is what we are going to do after watching the videos. I'd like to hear from you guys. I'd like to hear the kind of intersections you've probably worked on, the kind of intersections you've traveled through, the kind of intersections that you've probably had a lot of trouble with, and the intersections that you've had a smooth time with. So I'd also like to know which country you are joining us from. So as the video plays, please stay keen and also sacrifice a second to drop your country's flag in the comment section. All right, so I'll replay the video, watch it keenly, and then we are going to have a short interactive session or a brief interactive session centered around the same discussion as the video will be played. So I'm waiting for the video to load, and I'm happy to see a lot of familiar names and also new names. I'm looking forward to hearing from at least most of you. My YouTube. Right. Here we go. Here we go. Here we go.
Traditional intersections are places where vehicles, pedestrians, and bicyclists cross paths. This
Please ensure you're muted. Please ensure you're muted.
presents many opportunities for severe crashes. The good news is there are intersection designs that are safer for everyone. Some of these safer intersections look very different. Others may look familiar, but require a different way to make left turns. The goal is to either reduce the chances for serious crashes or manage the circumstances around crashes to make them less severe. Whether an intersection crash is severe depends on three factors: conflict points, vehicle speed, and collision angle. Intersection conflict points are where the paths of different intersection movements merge, diverge, or cross. They can involve vehicles with other vehicles, vehicles with pedestrians, or vehicles with bicyclists. Where there is a conflict point, there is the potential for a collision between users. For instance, here are the conflict points of a standard intersection. All conflict points have the potential for harm, but left turn conflicts are especially serious. Of the 32 vehicle-to-vehicle conflict points at a conventional intersection, 12 are associated with vehicles turning left. Now, consider a couple different intersection design options. If it were a reduced left turn conflict intersection, vehicle-to-vehicle conflict points are cut in half. If it were a roundabout, vehicle-to-vehicle conflict points decrease from 32 to 8, including the elimination of all left turning and crossing conflicts. Other intersection designs are also effective at reducing or modifying conflict points, and all improve or maintain traffic flow while making the intersection safer. Next is vehicle speed. As speed increases, the amount of energy that can be transferred in a collision increases exponentially, creating a higher likelihood for severe crashes. Intersection designs that effectively slow vehicles through conflict point areas are relatively safer. Collision angle also influences crash severity. This diagram represents the relative degree of harm in a vehicle-to-vehicle crash at different angles. Traditional intersections present multiple opportunities for vehicles to collide at more dangerous angles, especially during left turns. Intersection designs that change the angles at which vehicles move through reduce the chances of severe crashes. Equipped with knowledge about conflict points, vehicle speed and collision angle, roadway designers can devise fundamentally safer intersections for people driving, walking, and bicycling. The roadways, including intersections, are for everyone. So, if you see a new or different intersection design in your area, you can know that your community just got safer.
All right. So I'll introduce myself again. I am Captain Gachimo Ithaka from RoadsUp, and we at RoadsUp, we are happy to have you here today. We appreciate you guys putting in the time and the effort and sacrificing tonight to be with us, to come and learn with us. So we have been preparing to host today's session. We have a lot to cover today, and it's currently 8:07, so I only have 8 minutes for interactions with you guys. So I'd like to hear from as many people as I can within those 8 minutes. So I'm going to center the discussions around where you're from, your country, here to introduce yourself. Feel free. This is a free space. It's a safe space for all engineers with us. So feel free to introduce yourself, tell us where you're from, the kind of intersections you've probably interacted with. I know by now everybody has traveled at least a couple of intersections in their life. So you definitely know one intersection of two. Maybe your experience working on an intersection. So you can also tell us about maybe the bad memories or the good memories or the good experience you have with certain intersections. So feel free. As usual, I don't like mentioning names, but in case I don't have anyone to at least talk with me, I'll have to mention a few names. So I hope you'll understand. Okay, feel free to unmute. The floor is yours if you are ready to unmute. Hey.
Edward Mackenzie from South Africa. I've dealt with intersections on access roads. Yes.
Nice to meet you. What is your name pronounced? Ezad?
Ezad, yes.
Nice to meet you, Mackenzie. Hello, Pedro. Can see you're unmuted. Pedro, we can't hear you if you're trying to communicate with us. So I'll request another person to unmute. Remember, you only have 6 minutes, so please use them wisely, be efficient, so that you can get to hear from as many people as you can. Yes, so I'll have to mention a few names. Abraham Nyanja. Muhammad Ali, please unmute. You don't have to raise your hand.
Hello, good evening.
Good evening.
Abraham Nyanja from Uganda. It's a pleasure to be here. I'm here to learn. I think I last interfaced with intersections in actual construction and at university, but I last designed them theoretically at university, so it's going to be a very nice journey. Thank you so much.
Thank you, Abraham. Adash KL and Muhammad Ali. You don't have to raise your hand. Feel free to unmute. Adash, Muhammad. Okay, so who's next? Belinda Ann. Will you represent the female engineers with us? Let's see.
Good evening, everyone. I am excited to be part of this course, and I'm really looking forward to learning more about intersections. And I'm as well eager to engage with all of you. I appreciate the efforts you are making to ensure that you're getting as much knowledge as possible. Thank you.
Thank you, Belinda. Guys, you don't have to raise your hand. Feel free to unmute.
Hi everyone.
Hi, Amos.
Hi, glad to be here. It's actually my first time to meet with you guys. It's my pleasure that I'm part of this team. I'm from Uganda. I'm looking forward to learning. Yeah, I think I'll be part of the team from today maybe and the rest of the days and the meetings. Thank you.
All right, Amos, you are welcome to be here. We are trying to grow the family as much as we can. So we welcome the numbers. Bring on your friends, bring on your family, and we welcome everybody to join us.
Thank you.
Next person, I only have 2 minutes. Patience.
Hello everyone, Kongara Patience from Uganda, civil engineering student at Ndeje University. I'm glad to be a part of Roads Hub. It's really been a pleasure joining this group, and yeah, I have done some intersections, but theoretically we had highways last semester, so I'm so excited to learn more from the Roads Hub. Thank you.
Thank you, Patience. We appreciate the guests from Uganda. I think we will have to come back there again. James came alone, he came hiding, but next time we'll have to tag along. Vincent.
Good evening to you all. My name
Good
is
evening.
Vincent, a practicing engineer as of now, and in CAD field. I completed from Ndeje. I graduated on 11th October last week, but once. I'm sorry I didn't invite Roads Hub to the party, but yeah, it was massive. And now I'm in the field, I'm working. Easy, but we shall be there. I'm happy to be here. I'm working on junctions, both transportation planning and junctions design. Yeah, so I'm glad to be here. Thank you.
Thank you, Vincent. Congratulations on your graduation, and we are happy to have you here. So I believe I have heard from a South African, from Kenyan, and a majority of Ugandans. So if you'd like, I'll give this opportunity to one more person. If your country has not been represented, I can see Nigerian flags, I can see an England flag, I can see an Indian flag, I can see a Tanzanian flag. If your country has not been represented, please represent your country. One person only. Your name, where.
Hello, good evening. Hello, good evening. Hello.
Yes, Ishmael, we can hear you. Please proceed.
Okay, thank you, James. I'm Ishmael Bago from Sierra Leone. Actually, I'm very much happy to be here, to be part of this family. I call it a family because every now and then we interact and we learn a lot. I haven't got the opportunity to work on an interception, but we are humans, we are here to learn. And we want to grab this opportunity. Maybe after this, we'll have the opportunity to design one. Thank you very much, also. God bless.
Right. Thank you. I missed a major part of that, but I thank you. I appreciate you. So, Engineer James, are you in a position to take over?
Yes, of course. Thank you. Thank you very much, Gatimu, for such an interesting first session. I want to introduce and welcome everyone to this meeting. And because I'm seeing everyone doesn't have the energy, please, I'm coming here to share with you all the energy that I have. It looks like the day has been kicking you guys. You're really down. I don't understand what is happening. But it's good to have you here during this session today. I'm very, very, very happy to have the 80 of us who are already here with us. And I'm also seeing a lot of flags here, and this makes me super happy for you guys. So I can see a lot of South Africa here. That is Murava, Kishimba, Tanzania, Pale. There's Kenya, of course. There's Uganda, Chemutai, Jonas. Chemutai, that is more of a Kenyan name. Blesia, Seliman, William Opata, Kanza again. Andash, good to see you from India, my brother. Then there's Kaitlin from the UK. There's, of course, Maxwell. I know this gentleman is from, I think this is more of Zimbabwe against Nigeria right there. Awet Beneye is right there from Ethiopia. And then, of course, Abhishek Kumar. People are saying it has been a long day. I've also had a fantastic long day, but then again, I decided to show happier for you guys. It's an amazing day. So welcome very much. Welcome to our community. And if you can be able to hear me, please drop a 1. Just drop a 1 in the chat box. Drop a 1 in the chat box so that I can be able to know that at least we are on the same page. Yeah, thank you very much. And today's session is going to be a very interesting. Roger that. Thank you, Pedro. Thank you, Love More. Hey, good to see you, gentlemen. I haven't seen you in here. Simon there, Mayala Seleman. Good to see you, gentlemen. Hannah, good to see you. Good to see you. Fanuela Chipa, good to see you. Good to see you. I can see you right there. So welcome to our community. And let me just start with the first and most important thing that I normally say. And this is fundamentally important for anyone who is joining our community. May it be for the first time or for the millionth or 92th time. What I want to emphasize is that our approach is being the ultimate engineer. So when we talk of being the ultimate engineer, is our mindset is that we are perceiving ourselves as the best versions of ourselves. We are perceiving ourselves as the best consultant engineers that we have in town. We are perceiving ourselves as people who are on a journey to equip themselves with rare and valuable skills. We consider ourselves as problem solvers. We consider ourselves as one people, one community that thinks with a unified brain. We consider ourselves as a community that is tolerant and sensitive to all our cultures, our languages, our ways of life, and therefore this is a community for everyone. So it is important for us to understand that we are also bringing what we call a community-based learning environment, where we are learning. I know in this community we have doctors, people who have who are professors. We have also people who are already in campus. We have people who are already working. We have people who have experience of 10 years. We have others who have 5. We have others who have 2. We have others who have 1. So the first thing that we say is drop the arrogance. We are here to learn and grow together. So we're in this community because we want to build each other. So that is the most important point. And then the mindset, of course, is if you're saying here, you're here to try. If you say you are here because you want to see how things work around here, if you're here because you want to half-heartedly do this, then you are wasting your time. We are in this community because we are committed to this purpose. We are committed to becoming the best we can with our small beginnings, with our small steps that we are making. So it is important for us to have that mentor. It's called a point of origin, how we need to reason and perceive ourselves. So that is it. I have made sure that you are thinking from the same mind. So the next thing that I will be talking about is today's session will be centered around intersection design. And intersection design is a concept, or it's an interesting topic because it is one of the, most people consider it challenging, others consider it complicated. But if you're in our community, you know nothing that is complicated to us. So that is the first thing. So if you're here and your mindset is, this is too difficult, let me go and see what this is done, drop it. Now, the second thing that I will be talking about is this session will be, if you want to build Rome in 2 hours, please drop it as well. So I have created a series of 3 webinars on intersection design, and each one of them will be interlinked to the other one. So for example, this is the first series, and in the first series, we want to build the foundations of intersection design. And in this case, we'll be starting with at-grade intersections. And by the time we get to the third webinar, we'll already have covered grade separated intersections. And for us to be able to do that work, because it's a lot of work that is ahead of us, it is important for us to build a foundation that is based on engineering principles, key design considerations, technical specifications that we have in the road design manuals, and then, of course, do our most and important part of being a problem solver or providing solutions. That is it. And just before I proceed, I want to know, when you hear about intersection design, and when we talk about intersection design, and this is how we do our sessions, pretty easy and interactive, what are the things that you would consider as a design engineer? So suppose Ronsab is a big government corporation, and it is hiring you as our consultant. And the first thing that we are doing is we are having a meeting with you, and we want you to give us just a rough idea of your understanding of what are intersections and what are the key considerations that you would put in place if you are contracted to design one. I want to get just 3 answers. You don't need permission to speak, just unmute and take it away. What are the key considerations that you would have if you are designing an intersection, and what is your understanding of intersections? Please, someone, let's make it quick.
Safety.
Yes, please.
Sight distance.
What do you mean, sight distance? Those are the factors. Yes, Vincent?
Okay. According to me, when you're going to design the intersection, one, of course, what you're supposed to do first, you're supposed to know the OD, the origin and destination studies of the vehicles at that particular junction you're going to design. Then after knowing that, now you take in the design considerations. You must look at the stopping side distance at that particular point where you're going to design. And maybe you must look at the type of junction you're going to have. In most cases, you may find it is a T-junction or it is a four-legged junction. So in that case, you're supposed to look at that also. And when you look at that, you're supposed to also consider if it is already existing, you want to upgrade it, you consider the gradient of the existing road and you align it with the junction you're going to put. Then another thing that you're supposed to consider is the land where you're going to have your junction. In the neighborhood of the junction, what is surrounding the junction? Do you have houses in it? Do you have barriers like obstacles that are going to limit the sight distance of the drivers? Yeah, ideally, those are the things I would consider as a design engineer for intersection.
Absolutely, absolutely. Thank you very much, Vincent. And I like your delivery, and it means it's something that you put your thoughts into. And when we are doing these interactions, please make it as something like that. It's like you're doing a presentation so that also other people can be able to learn. So if I heard you right, Vincent is of the opinion that if you're doing any design for an intersection, it is important for you to, number one, take note of the origin and the destination of the vehicles that are using or applying that route. The second thing that I heard was about the type of intersection, which of course will be determined by the number of maneuvers, that is the type and the number of maneuvers or movement that you expect at that intersection. And then he's also talked about upgrading an intersection, because ideally, if you are a designer, it means you need to take it to the next level. You're designing for 10 years from today. So that talks about upgrading. And then most importantly, this guy is also considering the neighboring, the compatibility of your design with the neighboring infrastructure. That was spot on. Let me hear from one more person. For others, we can be able to use the chat box as well. Let me get to hear who is next. This is our session. Let me hear. One more person.
Yes, hello.
Yes, Kwaku.
Yes, I'm Kweku from Ghana.
Yes, please.
Okay, so during an intersection design, one of the key aspects is the geometry. So here you can consider the kind of vehicle that is using the intersection and the size of the vehicle and the turning movements so that you'll be able to do your curves well. So that is one aspect that you can consider. Thank you.
Absolutely. Actually, thank you. It's good to see. I saw your name, and when I was in Ghana, some guys told me they named me it was Kweku James or something like that. Yeah, so this gentleman is talking about the design vehicle. And this is very critical. The design vehicle that you expect to be using your intersection. I know we have seen scenarios where vehicles are driving over the capstone, or sometimes even going outside the provisions of the existing carriageway, because probably the designer didn't have that specific type of vehicle in mind. So thank you very much, Kweku James or Kweku Frimpong. All right. Next person, please. I wanted 3 people. Let me hear. Someone from the south.
The efficiency of the intersection.
Yes, Sonia.
Yes, the efficiency of the intersection. If it's able to meet this traffic demand, like the traffic, if it's able to how would I put it, to sustain the traffic capacity of the road. Yeah,
I agree with you. In this case, we are talking about what is the capacity of the intersection. Is it able to evacuate the traffic at that specific point? What is the traffic that is passing at that specific intersection within an hour or so? So thank you very much, Sonia. That is very important, and that is taken care of. Let me look at the chat box. I'm seeing people here are welding. Izan says you need to understand how your intersection is going or how you're going to manage the traffic flow. Yes, of course, I agree. That comes also during the design and also construction phase. We are seeing from Eyaku, Alfred says, I would consider the drainage and targeting. Drainage, very important, and targeting capabilities of the different alignments to form the intersection. This gentleman has gone all the way to designing. So anyway, get it. For your talks about environmental impact, of course, then Murava is talking about providing appropriate lane width and turning radius and avoid steep gradient. What is the other one? Other road users, which include pedestrian. Yes, Renee. So in this case, also, when you're designing your intersection, you need to look at who are the expectant road users at that specific intersection. So, ladies and gentlemen, you will allow me now to do a small presentation. Okay, yes, Mayala, avoiding the conflict points and improving the level of service. Level of service is the most fundamental aspect when it comes to intersection design. So, ladies and gentlemen, engineers, allow me to make a small presentation that I had prepared for you. And this session will be delivered in 3 ways. The first one was the interactive section that we've already had with you now. That was for you to share your thoughts. The second one is when I will be making a short presentation, which is ideally to cement the engineering principles that you need to keep in mind as we do with the intersection. And then the last point will be, or not last, but the next session will be about doing a Q&A that is centered around the engineering principles. And then after that, we'll be able to do a practical session where we can be able to do the actual design. So I hope you take note of this. So we're already done with the first part, which was the interactive section, where we wanted to gain your insight on these. And now we are going to the presentation. Please ensure that you're muted during the presentation. Should you have any questions or a point to add in what I am already presenting, please drop it in the chat box, and I'm going to respond to it during the Q&A at the end of the first presentation. So, ladies and gentlemen, allow me to share what I had prepared for you. Let me see that, right there. All right, that is it. So this is ideally, please drop a 1 if you can be able to see my screen. Drop a 1 if you can be able to see my screen. I am also going to unmute to hide my camera so that you people don't get distracted, so that we can be able to focus. So thank you. I'm still here with you. I'm the same that is presenting. So this session is, of course, courtesy to our one and only RunSub, which is basically your child. And what we wanted to talk about is the detailed intersection design in Civil 3D. And this is part 1 of the series, and we'll be able to do part 2 and part 3 on the same. And this is one of the things that we wanted to share. So this was captioned here, where we were talking, what is your general understanding of intersection design? So when we are talking about intersections, this is a point where more than one road get to meet. And we're also expecting that we have more than one type or more type of vehicles that are meeting at that specific point. And of the key considerations, those are some that we've already been able to share in the last session. And then what are some of the innovative ideas you have thought about or come across for intersection design? For this case, I will ask this question at the end of my presentation so that we can be able to share thoughts on the same. So the content of what we're going to look at today, I know it's pretty packed, but I hope and I believe that God is going to help us to deliver this. And the first one was, of course, the general design considerations. So in this case, we are looking at what are the functions of intersections, what are the objectives when you're designing these, and of course, the capacity of intersections. The second one will be about alignment and profiles. When we talk about alignment and profiles, we are going to look into these when it comes to the practical part of it. And then the most important one is, of course, site distances. And in this case, we'll be talking about the site triangles, the skew angles, and also what is called the visibility splay when it comes to both approach conditions and stop conditions. Then after that, we'll be talking about turning roadways, where we are talking about channelization. That is where we use ghost islands or traffic islands, and then also delineation of teardrops and what specifications do you need to consider for you to give or to position these islands, teardrops, and other different channelization methods. And then after that, we'll be talking about auxiliary lanes. And when we talk about auxiliary lanes, we'll be talking about acceleration, deceleration lanes, left turn lanes, and also right turn lanes. Then after that, we'll be talking median openings. Of course, we know we are not going to spend a lot of time when it comes to median opening, because also median is restricted according to the land availability and the amount of right-of-way that you have. There you go with right or left turns and U-turns. And then, of course, this is fundamental, but I've called it miscellaneous consideration, which it encounters pedestrians crossing, of course, traffic control. This is where we talk about whether this is a signalized or unsignalized intersection. And then, of course, the frontage roads that we have. We are not going to talk about rail crossings in this presentation, but we're going to cover it in presentation number 2. And then let us just get into it. What is the geometric design of intersections? So the geometric design is basically very easy, which is a combination of the 3 fundamental or 3-dimensional features of an highway. And then when we are talking about 3-dimensional features, we are talking about the horizontal alignment, the vertical alignment, and then the cross-section. For those of us who are already conversant with Civil 3D, we are talking about horizontal alignment, vertical alignment. The cross-section will be referred to as the assembly. And that is ideally the 3 dimensions. So that is what you want to bring in place for it to form your highway. But then what is the main objective of geometric design? And this is where most people get it wrong. The objective of geometric design is not to do fancy things. It is ideally for you to provide a safe. That means you need to put in place all safety considerations in your design. And then we are talking about efficient and cost-effective roadway. When we are talking about efficiency, is the ability of your design project, that is the intersection or even the highway, to be able to serve the road users. What is the classification of your road? Is it for mobility? Is it for access? Is it being able to efficiently serve that specific purpose? And then cost-effective roadway. And this means that, for example, you need also to have economy when it comes to your design. So in as much as you want to have safety, you don't have to recommend extravagantly large sections, radii and such, just because you want to have a safe road or an efficient road. So it is a balance between these 3 main aspects. And then, of course, you need also to address conflicting needs or concerns. When it comes to needs and concerns that comes along, especially in intersection design, is the land. what amount of land do you have available at that intersection? What road users are going to be using that specific area? How are you incorporating motorized and non-motorized traffic at that intersection? How are you taking care of people with disability at that specific intersection? And then when we talk about intersections, these are unique roadway elements where conflicting vehicle streams, and of course, sometimes it includes also non-motorized users, share the same space. If you look at the picture on the right, this is ideally a section that is demonstrating a four-leg intersection. And in this intersection, it has 32 number of conflict points. All of these are conflict points that are possibly or that can possibly happen at this specific intersection. And therefore, the main objective that we are aiming to achieve is to facilitate the road user to maneuver and enhance efficient vehicle movement. So ideally, our only goal and objective in this session and the consecutive ones that we'll be having is to enable or to facilitate the road users to navigate these intersections efficiently and safely using the shortest distance possible. So the need to provide, this is where now, for example, one of the ways we get to do is to provide extra time and space for drivers to be able to perceive, make a decision, and navigate through the intersection. You get it? So when we are designing the intersection, we need to put measures in place that will allow, number one, it is giving the driver extra time to perceive, or it is giving them the visibility. This is what we're calling the visibility space. So the driver is able to see the entire intersection. And then within that short time, it means they need to be at a very slow speed, not necessarily very slow or a slower speed, so that they can be able to decide and then navigate through the intersection. And now this takes us into the next step. So our objective here is we want to allow the road users to be able to navigate the intersection. So what are some of the basic elements or the intersection elements that we are going to look at? Remember, most of the people that are using the intersection includes pedestrians, cyclists, passengers, passenger vehicles, personal cars, trucks, and transit vehicles. And ideally, at an intersection, it will include so many elements. But these elements have been grouped into four main categories. The first one is the human factor. When we are designing intersections, we are designing them for humans to use them. But then again, if you are living in Elon's world, we have the self-driving vehicles. But in the human factors, we need to consider the following. What are the driver habits? And this is one of the most important one. And in this case, it is one of the most difficult aspects to control, especially in developing countries. Most of the accidents and causes of traffic jam at intersections mostly comes due to habits of the drivers. How are drivers perceiving and using intersections? And we also consider what is the decision ability of the drivers. What time do they require? That is called the reaction time. Do they require to make a decision? So So ideally, we know by practice, we talk about 2.5 seconds, but ideally some people will take longer than that to make decisions. We also need to look at what are the paths of movement. So ideally, this talks about the navigation and the movements that you have here. So if you're expecting the red vehicles, what do you expect? What path do you expect any vehicle that is coming from the left, the inner lane here? Where do you expect them to move to? Then the second thing is the traffic consideration. And when it comes to traffic considerations, we are looking at what is the classification of the road. So ideally, you will find that, for example, a four-leg intersection is something that you would not recommend in a major highway. Reason being that is going to be a nightmare at that specific point. So in such a scenario, that is where you recommend or a major highway, you're expecting that it has very high traffic volumes. So a four-leg intersection will be causing the 32 conflict. So this is where you see proposals for having roundabouts, which reduces the 32 conflict points to 8 conflict points. We'll be seeing at grade separated intersections at that specific point. They can be expensive to construct, but then again, it will save a lot of time and congestion at that point. Then we are talking about the capacity of our intersection. So you need to carry out a traffic survey so that you can be able to know what is the expected capacity here and what is the projected traffic growth in 10 years from today. Of course, for those of us who have done traffic calculations, you've been able to take into consideration how to project traffic growth. And then the second one is the turning movement. So when we are talking about turning movement, is we need to understand, are we having left turn or right turn? In most instances, depending on your country, for example, in Kenya, we drive on the left. So right turn movement causes all the traffic congestions and accidents in most instances. Right turn. So this means you are going to cross the traffic or cross the incoming traffic. What this ideally means is someone is unmuted. I don't know who is that. Please get to take care of that, Captain. What this means is you need to know what is the number of movements or maneuvers that I'm expecting at my intersection. And we'll be demonstrating that shortly in the design, in the practical part of this design. So what are they expecting? Am I merging? Am I weaving? Am I crossing? It is cutting the traffic at that specific point. So we have merging. That means the traffic is moving from this point and, this vehicle is joining this other lane. And then we have diverging. It means it's moving from its lane, moving to another lane. And then we have cutting. It means that it's cutting at an angle of 90 degrees, probably, or 60. And then there is also cutting where it cuts directly at 90. Remember, there is cutting at an angle of probably 60. And then there is a cutting at an angle of 90. And then there is cutting and merging. So it means you have to cut the opposite traffic and then merge into another lane. And then there is compound cutting and merging. And that is where now we talk about having a great separated intersections. Then the other element is the physical elements, and all of these elements, we are going to see them in the design. And when we are talking about physical elements, and I think this is where Vincent really spent a lot of time, it was abutting properties. So how much more or how much dislocation or relocation of abutting properties and utilities will you require at a specific point for you to do the intersection? So these are the things that you need to consider and document. The only way to do these physical elements, remember the first one for traffic consideration, you have to do a 7 days traffic study or traffic survey for that specific area. And then when it comes to the physical elements, you have to be there on site, abutting properties. What are the possible site distances that we have? We'll be talking about site distances in the next slide. And then we'll be talking about what are the specific conflict areas. And this is the most important aspect, the physical elements. When you're designing intersections, intersections are not theoretical things that you get to design according to I don't know what. Intersections are designs that you customize to solve problems at that specific area. There is the general layout that you expect, of course, that is guided. But when it comes to the conflict areas, it is you as the engineer to think, what are the possible solutions can I be able to provide at intersection X for me to ease the traffic congestion at that point? And then, of course, we are going to talk about that is where you see people doing what we call, there's a kind of displaced left turn, displaced right turn. And this one gives there's someone still who is unmuted. Please, Captain Tony. It's Muhammad Ali. Gentlemen, please. Yeah. So we are talking about the conflicting area. That is where you see displaced lane. That is where you see engineers adding, for example, some slip roads that can be able to evacuate traffic at that specific point. That is where also we provide speed change lanes and also storage lanes at that specific point in place. And then, of course, at this, we'll be talking about, is this intersection, does it require to be traffic? Is it controlled? Is it signalized? Or what type of intersection is that? And then we'll be talking about also lighting, roadside design, environmental, crosswalk, driveways, and also access management. These are all things and aspects that change from site to site. They change from one location to another. So we cannot have a one-size-fits-all design for an intersection, especially when it comes to traffic considerations, physical elements, and also human factors. Because drivers in Kenya behave completely different from drivers in India. And then we are talking about economic factors. I think that is obvious. You need to have consideration for what the aspect of constructing the proposed intersection. And these are the traffic considerations that I was talking about. So we are talking about roadway classification. So you can see, for example, the higher the classification of the road, like for example, the one that I have here for you, it means that you have many conflict points that you want to have at that specific area. You have as many, so you will need U-turns, you will need different ways. And you can see, for example, this intersection has been reduced. So this one, if it was a four-way or a four-leg intersection at this point, we would be having 32. But now we have introduced U-turn and displaced left and right turns. Mostly this is left turn. You can see it has reduced these conflict points to 16. But then again, if you go to the roundabout, it is going to reduce them to 8. So this is the same aspect that requires you when you are looking at intersection, and I'm talking to you also, Vincent. If you go to this specific site, what are the conflict points, the possible conflict points that I have? What is the amount of size, what is the size of land that I have in this specific area? How can I be able now to break down, or which solution would I recommend for this specific area so that I can be able to reduce the conflict points to as minimum as possible. So in this case, we are talking about roadway classifications. Of course, that is given. The turning movements that we are talking about, merging and cutting. And then we are talking about vehicle speed. And this is the most important aspect. And the design speed, the junction design speed, is the principal design parameter upon which the geometric layout and the capacity of a junction is based. And what this means, for example, if you see this, the intersection at the top, which is basically more of displaced left turn lanes, it means that vehicles can move at considerably a higher speed compared to roundabouts. So when it comes to roundabout, you are expecting a very low. The whole idea of designing roundabouts is you want to reduce the speed of the vehicles so that they can move through the concentric movement at slow speeds. And then we'll be talking about when it comes to junction design speed, there is the rule of the thumb. And I'm going to state it to you now. We use the design speed of the major road to design the intersection. So if the major road design speed is 80 kilometers per hour, so how do we determine the design speed of the intersection at that specific point? These are the two rules of the thumb that I'm going to give to you. And when I talk about rules of the thumb, it means they are generally accepted approaches, but they may vary according to design specifications in different countries. And the first one is this one. For reasons of economy, the junction design speed shall not be more than 20 kilometers higher than the average design speed of the major road. So what that is telling you, if the major road has a design speed of 80 kilometers per hour, you cannot say that my intersection, I'm designing my intersection at a design speed of 100. Actually, you cannot even design an intersection at a design speed of 80 kilometers per hour. Now, the second one, for safety reasons, the junction design speed should never be less than 20 kilometers per hour, lower than the average design speed for the major road. And these are very important, fundamental principles, because it is only if you can be able to choose the design speed of your intersection that you'll be able to go and design in Civil 3D, that you'll be able to get the different parameters that you'll need for your intersection. So let us agree here. If the design speed, let us assume that our road has a design speed of 80 or even 60 kilometers per hour. Let's just use 60 kilometers per hour. So if the design speed of our road is 60 kilometers per hour, it means our design speed for the intersection shall be something around 50 kilometers per hour. Because we said it should never be less than 20 kilometers per hour lower than the average design speed. So if you're going below 40 kilometers per hour, that's more of a risk for rare accidents. And then after that, there is crash history. And this is very important when you're doing intersection design. And this is where we conduct surveys, origin, whatever destination, OD surveys, and also interrogating the road users. Where do we find most of the accidents here? which side of the road causes more accidents? Where do we see more conflict in this case? So that you can be able to reason, how do I sort the vehicles that are moving from leg X or leg Y? And then again, of course, at the end of the day, you need to consider, am I supposed to integrate the NMT, bicycles and pedestrian, in my design? And I think this is compulsory in our days. And this is, of course, what you saw here with also physical elements that you need to have. And for example, what you're seeing in this picture is ideally a replication of every physical element that you need to consider in your design. Number one, you can see the abutting properties. So for example, in this design, because this is more of another intersection, and I will tell you the name of this intersection, it's the one that we are calling the left lane, displaced lane, DLT. And we have the sight distances. You can be clearly, everyone is able to see. And remember, for example, the intersection is somewhere here around this building. The intersection is not here. The intersection is is at this point. And ideally, this type of displaced left turn, whatever, allows you, it displaces the left traffic on the left lane before it gets to the main intersection. So you are deflecting the left traffic here, the left lane before it gets to the intersection. And then, of course, this section is controlled with a signal at this specific point. And then we are talking about lighting. So you can see this is a clearly open area. So there is no lighting that has been provided. And then, of course, speed change lanes. You can see this is more of an acceleration section that we have at this specific point. And basically, these are the physical elements that vary from site to site. And then we go to the types of intersections that we are expecting. So we have the three-leg intersection. So the three-leg is the most common type of intersection that we have, and it is called the T intersection. We also have the four-leg intersection, which has the highest number of conflict points. And I think it's the four-leg intersection that allowed engineers to explore the different ways. And ideally, when we have a four-lane intersection point, what we try to do is the simplification of the complex junctions. You wouldn't want to have a four-leg intersection at a lot of points because it's a nightmare. If one person gets in the box, that's it. Everyone else is locked. And then we are talking about multi-leg intersection. Of course, this now goes all the way even to at the Great Separating. There's, of course, the roundabout, which is one of the good ways to evacuate traffic at intersections. We have clovers. These are Great Separating. We have jag handles. We have trumpet intersections. And then, of course, cloverleaf intersection. We'll be looking at how to determine the different type of intersection that you're going to use at every location. And the first one is, of course, the topography of that area. So you will find that at flat terrain, it becomes a little bit more expensive for you to propose grade separated intersection, because ideally it will require you to build all those abutments at that specific area. And it will require a lot of fill material at that specific section. But then again, if you go to mountainous sections, you may find it is easy to cut. You will find that difference in elevations, but then again, also, it becomes expensive when it comes to vertical alignment again. And then there's the traffic characteristics. What are the vehicles are you expecting at this area? What are the size of the design vehicle that you're going to consider? The number of legs that you have at that specific point. And then the type of operation, ideally, this is also the angle that you think vehicles will be getting at that intersection. And you can see the higher the red section, it means that there are more severe collisions that they happen at this point if vehicles intersect. And you can see ideally vehicles that are intersecting at lesser angles of 60, 30, this is 0, almost 180, 330 right there. It means there is less severe impact in case of an accident. And let us just focus on the 3-leg because that is the first intersection that we have. The typical 3-leg intersection configuration contains the normal paving widths with paved corners ready accommodating the design vehicle. And this is it right here that you're seeing in the picture. So this is a 3-leg intersection. Don't worry about the speed change lanes here, the right turn and the left turn lanes. We'll be talking about them in a later part. And in this case, we are seeing vehicles moving from the minor road. This is called the minor road, of course, the T. And then the road that is moving across is the major road. So when we talk about a 3-leg, it means that we only have to give this ready for this curb return at this point, and then the curb return at this point. But ideally, the entire section is paved. It has the normal paving of a continuous section. So mostly what we do is marking, or at sometimes you can be having a raised curb at this point. So we'll be talking about the geometric configuration, but most importantly is the angle of intersection between the minor and the major road. And the angle of intersection ranges between 60 to 120 degrees. 60 to 120 degrees. The best scenario is going to give you an angle that is around 90 degrees. If you get your intersection at 90 degrees, that is good. What this is telling you is if you are doing the design of an intersection, it will be prudent for you to start with the intersection first, figure out the alignment and how the legs will look like before even you go to do the horizontal alignment ahead for the entire road section. Because what ideally this means is the intersection is going to control the alignment of the road at different scenarios. And that is when it comes to design perspective. When you're designing, you first figure out how will my intersection look like. And then it is only from that you can be able to continue and have the alignment of the entire section. So let us zoom in. I'm going to open another drawing here for you guys so that we can spend time and analyze the geometrics, because I want us to go there to the practical aspect of this work. And the first and most important part is for us to understand the basic layout. And I'm going to zoom it in here. So allow me to share my screen. I will drop this screen right here and then share again. And then so that I can be able to share my entire screen. And let us look at this one, my beautiful people. This is just a typical layout of a 3-leg intersection. So there is the junction layout type A, and then there is junction layout type B. The difference between junction layout type A and type B is because type A or type B is ideally for, how do I call it? It is ideally for a section that does not accommodate the left turn and the right turn lane. And it also doesn't have the traffic island that you need to have. But there are important aspects that I want you to note down, please. If you're listening to me and if you'll be attending the series, note this down. The first thing that is very important is the radius of the curb returns. The radius of the curb returns that we're going to use at this intersection type B is, let us look at this. We are assuming we are moving from the right-hand side, moving to the left-hand side. And therefore, on the left-hand side, we are talking about the radii of the curb returns. For you to get a very smooth transition, and remember about the turning radius and the design vehicle, for you to be able to accommodate all the design vehicles that you're considering, in this case, we are looking at the transit vehicles that are almost 30 meters long. We have a combination of 3 radii. And I want you to write radius R1, radius R2, and radius R3. And look at this point. The ratio between R1, R2, R3 should be 2:1:3. What this is telling us is the R2, the radius at the midpoint is always the smallest one. But interestingly, the radius at point R2 controls, or it is dependent, or it is tied to the turning characteristics of the design vehicle. This is where the vehicle ideally gets to make the turn. So the first radius R1 is ideally like a diverging section. It is a widening that you need to achieve for your vehicle to leave the main highway. And the moment the vehicle gets to this point, it means it should be able to be accommodated along this section before it gets to this point. So that is very, very important. Now, the numbering of the radii R1, R2, R3 is oriented, or it follows the direction of the flow of traffic. So look here, we are moving from right to left, and that is why we are having R1 as the radius that is diverging from the main road, it's the widening. And then we have R2, which is the turning, and then R3, which is the tapering into for the vehicle to continue to the minor road traffic. Let us go to the left-hand side, which is the south. This is southwest quadrant. This is more of southeast quadrant. This is southwest. And in the southwest quadrant, we are moving from the minor road to the major road. This is primarily very, very important. It is only after you get this right that we can be able to proceed with you to model the intersection. So in this case, we are having R1. The vehicle is diverging, or it is moving. Okay. Is it diverging, or yes, it is diverging from the minor road, and then it will require R2, which is the turning, and then it will require R3, which is ideally the merging now. The vehicle will be merging back or tapering back into the main traffic. And of this radii, remember R2, for a vehicle that is 30 meters, you require around 13.5 meters turning radius plus an overhang of around 0.5 or something like that. But ideally, we work with R2 being anything above 17.5 will allow your vehicles to be able to turn at that point. When you're talking about R1, you can be talking about anything that is above 25, 20, 25. And then, of course, R3, again, you need a bigger radius so that your vehicle can be able to tap back into the main road. So that is the configuration when it comes to the radii of the curb returns. And I want you to note this down because we'll be using them as we model the curb returns in a few. The second one is the teardrop, my guys. This is called the teardrop at this point. The teardrop at this area ideally is a separator. It's just separating the traffic, the incoming and the outgoing traffic at this point. Remember, the teardrop must be placed at least 2 meters. Actually, you can see the sign here is greater than or equal to 2 meters. So the teardrop should be 2 meters away from the edge of the traveled way. So ideally, it means it's from the edge of the white edge line, the white edge line, yes, the white outer edge line, 2 meters from that point. Otherwise, I was talking to an engineer who was telling me they didn't consider this aspect and they end a curb, a raised island or teardrop, and it was, you know, vehicles used to drive over it, Ideally, what makes these for you to have this allowance is because of this radius RC. Please write down radius RC. RC control is called the control radius, which is dependent on, again, upon vehicle turning characteristics. And you can see also R2 will be dependent of vehicle turning characteristics and proportion of large vehicles. And this is the most important aspect. R2 here, and then RC again. Why RC? It is this guy who is moving on the left-hand side here. He wants to join the minor road from the major road. It will require this RC, and it should be sufficient for him to turn whatever size of the design vehicle without driving over the teardrop. And you can see, for example, they are giving a recommendation. Recommended range for R2 is 8 to 12 meters. So ideally, if you work with something above, you know, those figures of, you know, there's the theoretical figure here, and then again, the practical aspect you're seeing on site, because also drivers are not moving on, you know, such as channelized path. So if you use anything like 15, 17.5 all the way up, then that is good. But then again, how you control these radii is, of course, based on economy. How much of surface area are you going to cover for you to design this intersection? RC again, so we can note down, we can say RC, we are going to use 15 meters. R2 again is depending on turning characteristics. So we can actually get to use 17 for RC, R2, 17. And then when it comes to R1, we can be able to use something like 20. And then for R3, we can be able to use a radius, a bigger radius that's more of tapering. So we can be talking about even 25 meters. I hope you've taken note, you've noted those down so that we can go straight into the now practical application. Now, this is the other point. When it comes to the teardrop, the positioning of the teardrop is the intersection between RC and RC. And this is where most people struggle with this scenario. And it is difficult. And most people struggle with it easily. Because even if you want to go to do modeling, and most people focus, and this is where we get it wrong, engineers. Most people will be ignoring the things that I'm telling you here. And you want to jump straight into modeling the corridor in Civil 3D. The corridor modeling in Civil 3D can only be achieved if you get the geometric parameters right here. And this is another interesting, where we have now the highlands. And I will be covering the teardrop location here. So you can see, number one, the teardrop location is between 2 to 4. So 2 meters is fairly good. That is the teardrop location from the white edge line, or that is from the ETW. And then there is the ghost island that separates the incoming traffic. Remember now, this one, you're doing this in more of a dual carriageway or a traffic or a single carriageway that has a higher capacity. So you want to separate these, and also you're expecting to have a lot of right turn movement. So the radius here, the exit radius should be 25 meters. You are having a ghost island. Someone asked me what are the specifications of the ghost island. And ideally, when it comes to design, the ghost island should be able to create itself. Ideally, you offset this line 1 meter to this point. And then remember, there is the center line of the minor road. You offset it to 2.5. And you can see something less than 2.5 is allowable for you to be able to give. These are the specifications that you have for the teardrop. So once you offset these lines, you will also going to offset it to width 2, which ideally is the vehicle that is moving from the left, that is making the right turn here. So you have another 3.0 meters, and then you will have the line for the ghost island in this case. So if you have the line for the ghost island, and then you are going to have a radius of 25. And remember, in such a scenario where you are having or you are locating a ghost island for vehicles moving from the major road, you don't use the three centered arc or curb return. That is very important. When you are providing the ghost island for this case, for incoming traffic to the minor road, that is traffic that is moving from the major road to the minor road, you do not use the 3-centered arc for your curb return. But then you can see for the exit, where we don't need the ghost island for this case, because you're only having one-way traffic rather, it requires the 3-centered arc. So ideally, there are 3 arcs as a widening or as an acceleration section for the vehicle to be able to move into the major road. So I think that is super clear. So I can go straight into the next part, which is ideally now to demonstrate how we can be able to use these principles in design. So please drop a 1 if you can be able to see my screen. And then let me post whether there are some questions. I'm seeing 35. All right, I'm seeing 35 messages. Let me see. Other roads users which include the pedestrian. Okay, there is no question that I need to address. There is no question. Okay, I don't know what is happening here with my chat. But I'm seeing this is the last guy that texted me. All right, great, super. So that is basically the geometric layout. And this is the most important aspect. Okay, Rini says the last point regarding the ghost island is still confusing me. Please write down your questions. You can be able to ask. I will pause so that you can ask me your questions, and then I'm going to respond. So Rini, please, you can come up again.
Engineer James, must I write?
Sorry,
must I write in the chat box?
No, you can speak. You can speak.
No, I was a bit confused in terms of when you were talking about so you're saying you don't need the 3-centered arc when you're creating the ghost that small ghost island. Is it a ghost island?
Yes.
So what I'm saying is, okay, let's say okay, let me say the lane width will be let me say 3 meters, the one that's coming from it's turning, and then the other one with the rate, the W2 will be also 3 meters.
Yes.
So basically, where they meet if you extend that point where they meet, this is where they will actually create, will automatically create the ghost island.
Yes.
Okay, no, I see it now.
You understand it now?
Yes. So you would have actually, but wait, just one more thing. The 1 meter is between the edge of the travel way of the major intersection, that one. And
yes, this one.
Okay, and then the other one is but now I'm confused between the Oh, I see it. Don't worry, I see it. I see it.
You see it? So we are having the center line of the minor road, and we'll do the 2.5 here. So of course, this one is also dependent on the available land, and you can see the ghost island can be even lesser than 2.5, okay? And then once you offset it by whatever is available, say 1 meter, and then after that, you will have the 3 meters for your lane for vehicles that are moving from this point, okay? And then so if you offset this line to here, you see it will form that line naturally. And we had already previously, offset the edge of traveled way at this point, okay?
With 1 meter.
So you can see it has already formed the 3 points. So the other one will be knowing that I need a radius of 25 for me to be able to connect these 2 points. And that is where now you will do a little bit of widening here, and then boom, it forms itself. So what you need to do is now offset this again by 3 meters, and it will form this arc at this point. So all you need to do now is to trim these edges, and the ghost island will form itself without you necessarily going to do the specifications on what you need to do that area.
Thank you so much.
You get it, right?
Yes, I do get it.
And the other point that most people get to miss, please, it is this distance for the teardrop. It should be at least 2.0 meters. Please don't forget that, okay? And the radius for this section, it must be 25 if you're providing the ghost island. So this allows, it is a larger section for vehicles to be able to maneuver. So if you do a 25 radius here, it means this section, you can see naturally this section is wider than the one that we are using, the 3-centered arc. The 3-centered arc also reduces on the amount of space that you're going to require for your intersection. And then from this point, this one is natural tapering. So this one is also dependent. This section here, this section, it is dependent on the amount of road reserve that is available. So if your road reserve is, let's say your ROW or right of way terminates at this point, this means that we have parcels of land at this area. So it means for you as the design engineer, you need to figure out how you're going to taper your road to accommodate the allowable width, that is the normal width of the road, that is ideally 7 meters before it gets to the right of way of the other, or rather before it gets to the property. I think that is common sense at that specific point. All right, thank you. Let me see. In case of the intersection, this is Kataboy. I know you, gentlemen. In case of the intersection point joining at an angle other than 90 degrees, does the recommended R1, R2 apply for? There will be other considerations for this. Ideally, even if the angle changes, you must provide the radius that will accommodate the vehicles to navigate at that specific area. But then again, there is the option of realignment. And that's why we were talking about, if you are designing an intersection, it is important for you to start with a road with an intersection. It is important for you to figure out the intersection first, and then you can be able to realign the other section to this area. The recommended, you can see we are working with an angle of 60 to 120 degrees. That is the range. Anything beyond that, it will cause a lot of accidents and, of course, a bottleneck at that specific point in case. So in this case, it looks like I'm not going to be able to cover the left turning, like whatever. But anyway, let me get into it. So you guys were with you, and I hope we'll be able to manage these. I've not been very well in managing time today. So we are talking about now the other point where the specifications for left turning lanes. So ideally, depending on the capacity, it's even written here, auxiliary lanes, that is either left or right turning lanes, may be used to increase roadway capacity and provide better operational conditions. This goes to, it was Sandra Morara, something like that. I think she mentioned it. This is why we provide auxiliary lanes. Ideally, this means that you've made the traffic study and you've seen if vehicles are allowed just to join the minor road and the major road naturally without an additional lane, it is going to cause congestion at that point. So that is why you provide an auxiliary lane. It is the same instance where you provide for channelization of vehicles. And when we are talking about channelization, that is why we are having the ghost island or the traffic island. You want to channelize your traffic specifically to this lane to avoid the confusion and the chaos that comes with it. And when it comes to this length of left turning lane, how do you determine their length? The first one is the junction design speed is very important. Ideally, you will find that the junction design speed is always less than 70 kilometers per hour in most instances. And therefore, the length of the deceleration lane, this is the layout, ladies and gentlemen, for the left turning lane, okay? And remember, this is where we are widening the major road so that we can divert this traffic. It means the minor road has a higher capacity as well. We are having more vehicles turning to, I think it was a ratio, I don't remember the actual figure. It was a ratio, I think, of 1.5 or something. It means that more vehicles are turning to the minor road. That is when you provide a left turning lane. So ideally, this will act as a storage lane and also as a deceleration section. So for the deceleration section, if the design speed of the junction is 70 or less, you provide the length of the deceleration as 30. The length of deceleration is called LD, length of deceleration section. It is from this point. I don't know where this one gives me the functionality to use a pen. I don't know where it went. I used to use this sometime. I know Wesley is not here. He's the one who helps me with these things. So yeah, so this is it. And then the width of this section should be 3.5 meters. But there is this tapering that we have at this case. So the tapering, of course, we are going to look at it in this case. Let me just go back to this case. We've seen the deceleration lane should be 30 meters, and that is what is called LD. And then in LD, I think I forgot to snip the other part. There is LC, which is basically like it's more like another 30 meters for this case for you to taper. So the vehicles have to taper from this point all the way to here. This is the deceleration point. And then after that, now they can be able to move into the minor road. The other case, this is now a scenario that is simulating a right turning lane. And in the right turning lane, again, you see this is the major road. And in the major road, since vehicles in the major road wants to turn into the minor road, you provide a storage lane. So this right turning lane is basically called is also called a storage lane. And in the storage lane, again, the LD in this case should be, of course, 50 meters. Let me just not give you figures. It is dependent on your road design manual that you have. So, but ideally, as a rule of the thumb, again, we use 85 meters. And this is what I've seen in most roads that have a design speed of 80 kilometers per hour. You are talking about a rule of the thumb where you are having the deceleration and the storage lanes being at least 85 meters. So you have a deceleration or an acceleration section of 50 meters, which also acts as a storage lane in times of traffic. And then again, we have the diverging section that has 35 meters. So the diverging section helps the vehicle to merge or diverge away from the main road. So in this case, this is the LC, that is the diverging section. So the vehicles are able to detour so that they can be able to merge to this point, and then they will be able to decelerate at this point and then make a right turn right there. So in full context of a section that is having the speed change lanes and it is having the right turn lane, and it has a widening on the major road, this is how typically it looks like. And this one, you must have this image in your head before you even go to design. So ideally, the trick is always with controlling the through traffic. So the through traffic that is running here must be able to move unobstructed. It must be able to move unobstructed, and therefore that requires road widening, mostly on the outer lane here, so that the through lane can be able to move unobstructed. So if someone is moving from point A to point B, they just go. And then in between these, we provide the right turning lane, which is, of course, the storage lane at this point. And we've talked about, you can see the specifications have been given here. Your road design manuals may be having different specifications. So it's good to consult that we use in your different countries. And ideally, you have the width of 3 meters as the minimum. We have a radius of 500. This means this is more of a circular section. The connection here, it's a curve. It's not a straight edge. And then the radius of this point is very important. Remember, the storage lane is only on the approach side. It is only on the approach side. It is not in the this is the approach, this is the departing point. So if vehicles are moving to this other side now, we don't have a lane at this specific area. But then again, remember, these are concepts that can be customized according to the site conditions that you have at that specific point. So we'll be talking about intersection site distance, and I hope you've noted this down. We'll be using them in our next webinar. And in the intersection site distance is the length of roadway along the intersecting road for the driver on the approach to perceive and react to the presence of potentially conflicting vehicles or hazard. I think in the Kenyan road design manual, they don't call it site distance, intersection site distance. In AASHTO, American standards, they call it intersection site distance. In Kenya, they call it visibility splays. I don't know what you call it in your country. Please check it. And these visibility splays are ideally tied to the design speed. So the design speed, if you're having a design speed of 50, it is going to tell you you need a distance of at least 135 meters from the center of the minor road, 135 to the left and 135 to the right. So ideally, it means when the driver, and this is for approach condition, and in approach condition, we are considering someone who is moving from the minor road and they want to join the major road. They are moving from the minor road, they want to join the major road. At 20 meters away from the center line of the major road, the driver should be able to see at least 135 meters to the right, 135 meters to the right. And this is where we control roadside development. This is where we control encroachment. And I remember it's a sad situation in Kenya where hawkers and roadside vendors were swept away by a fuel tanker, because they were within the road, within the road reserve. It is a scenario that we see in most places, and it is one of the major challenges that we have, I think, in most developing countries. We have shops and kiosks that are just next to the edge of the road, and ideally they obstruct the visibility of the road user at that point. So you can see it right here, you need to be able to see, I'm going to share this with you guys so that you can be able to check it out. And also please check out from your country so that you can see what specifications do they have. So this is just but a guide. In the American style, that is the AASHTO, they use what is called, they use the approach site triangles. And of course, if you look at this one, they are a little bit more inverted because they drive on the right-hand side. But ideally, it is the same concept that we are using when it comes to visibility splays. And you can see the decision point is right here, which is ideally 20 meters away from the center line of the major road. And therefore, this means the driver needs to see, this is what they require. So for approach site distances, it means you require more area. And the decision point is a little bit far away, 20 meters. But then when it looks to departure, site triangles, this is for the departure, which is ideally for stop conditions. You can see you are making this decision when you are only 3 meters away. So it's like you want to depart. And this is ideally if you see yourself driving. When you're 3 meters away from the center line, that is when you want, it means you're already in the intersection per se. So you just want, you need a shorter or a smaller area, you know, you are closer, but it will require you a longer, you have a bigger view. You have a bigger view when it comes to length LS. LS is bigger when you are departing in this condition, and you can see it right here. So the hypotenuse of these visibility triangles or the site triangles is a little bit bigger than usual. And this one takes us to roundabout design, which I'm not going to talk about because we already did that. But ideally, that is the concept that you need to have. Now, how do you apply these principles in actual work? And this is where I'm going to send you guys, I'm going to send you guys, for everyone who is here, I'm going to send to you this drawing. I don't know how I'm going to send it, but I'm going to figure it out. But since you registered and you have your emails, I can email it to you, all of you people, and send it to you. But this is, for example, a typical site area. This is a typical site that requires you to have the, let me just delete all of this. So this is a typical site that you've been given, and you need to design it first. The first thing is not to go straight into modeling the corridor. The first thing is you must be able to establish the center line of the minor road and the center line of the major road, and make sure that this is the point where they intersect. That is the most important. And then after you've done that, you will go back to do the geometric layout as per this presentation here, my beautiful people. And this is why intersection design is so tiring for many people. This one, you must first be able to decide, am I going to have a ghost island? Am I going to, what type of intersection? Is it type A or type B? And then it is after deciding these, you must be able to get all these parameters right. And for you to get these parameters right, and this is now where the gist of it comes, remember, you do not have specific figures that you need to use. This is what is called context design. It means you will need to start, for example, from this point and do the first radii. And then it is from this point, you will go and do the second radius. And then from this point, you're going to do the third radii. And you can see, for example, my right of way is right here. So as I was earlier saying, is you need to make sure by the time your road gets to the right of way, you've been able to taper it back to the usual, or rather to the normal width of the road, because these are parcels of land for other people. So ideally, you need now to start figuring out, how do I do these radii? How do I place them? you know. And remember, already you've done your survey, you've gone to this site and you understand how the site looks like. So it is only you, after you've been able to connect these three arcs, you can be able to measure, for example, what is the radius of this one. I can see the radius of this is 25. The radius of this is 33. And then the radius of this one is 35. What is this? This is telling me is it's an extremely extravagant section. So it means I can be able to reduce this due to the fact of economy. I don't need to have radius of 35, 35, 35, 35 at this point. So I'm going to move closer, you know, move closer and position these arcs in such a way that I also don't have a too wide section at this case. And this is my work that I'm going to give you people. I want you to use those engineering principles that you've talked about for you to be able to get the geometric layout for this section. So for example, if you look, I look at this one, that is 33, that is 29, you see that is shorter, and then this is 16. So ideally, it means that I'm getting better and better and better. So it means I'm going to move more inside to this section. Remember, you don't need to have it extravagantly too big for your, you know, for your road section. Remember, you've already understood that the largest vehicle that will be turning here is, I remember the radius that we were given was something between 12 to 15. But of course, something that is bigger than that would still work. So for example, this is the most important radius, the turning radius 17. So it means ideally this is cool. And then I look at this other one. This is 37, fairly good. And then I look at this other one. It is what? This is 53. This one should be, this one is allowed to be extravagant. And then I can be able to taper it back to where it means the whatever, where it means this section. So ideally, what the next thing that you need to do is probably get to measure now, what is the distance from this point to this point, from this point to this point, and then start doing your offset so that you can be able to, so for example, this one was 2.5, let me say 2 meters. So I'll move it to 2 meters, and then I'll move it to 3 meters. Okay, so this means that's where my edge of traveled way will look like. So if I was providing something else, it means ideally it means I will be able to accommodate the teardrop at this point, and then at least I have an area for my vehicle to maneuver. So in as much as I want this section to be bigger, depending on the factor of economy, I may decide even to reduce this section to come closer to this point, you know. And this is where now we are talking about you being super practical, and you don't need to have very extravagant sections. So this is ideally a section for you to be able to experiment and make decisions as the engineer. What decisions? Have you considered all those other factors? You may remember, you may be having some buildings here, you may be having some stuff, valley, drains, and all of that. So it is up to you as the design engineer to make the decisions that you need to have. So for example, once you get to make those decisions, that is when now you come to this other point where, let me just freeze it out. And this is it here. So you can see I have my radius R1, 26. You can see I have my radius R2 here. You can see I have my teardrop well fitting. It is ideally 2 meters away from this edge. And then there is my teardrop, my traffic highlight is right in this specific area. And you can see it has created itself naturally at that specific point. So what I'm saying is I want you people, if you're genuinely interested in learning this craft, I am going to send this design data to you today or tomorrow. And I am going to upload this recording on YouTube. And just below that, I will attach the Google Drive file that will be having this DWG. So this DWG, the task that I have for you, I know you guys are so, I'm so audacious that I'm even giving you guys job and task to do. But this is my approach, and this is what I've come to understand. In all the design, in all the trainings that I've done, if you don't get to do the things that you just want to listen, ideally, it's like you're going back to school again. So if you want to learn, I want to send this DWG to you. And once I send to you, I will also share this PPT, this presentation that I had here. And you'll be able to follow through. I will also share the road design manual that I have. I will put it in that specific folder. And I want people to work on it. Get the geometric layout correct. And once you get the geometric layout correct, we are going to have another session that is part 2. So in part 2, we'll be doing the actual modeling using the parameters that you got in the previous section. Ideally, make sure that you make your project as great as possible. Use your imagination and exercise thoughtfulness, decision making. Be the guy who is designing. When you call yourself a designer, it means you are giving yourself the powers to make the decisions on behalf of your employer, on behalf of everyone else who has given you that specific task. So my ask to you, my beautiful people, if you can be able to do this, the better. If you feel that could be too much, do this. Ideally, you can actually be able to do copies, but a bare minimum will be designing this section as it looks here. I don't know what slide number is this, but I'm going to share it with you. I am also going to share the recordings and everything on YouTube and also in our communities. I want you to take the action. Remember, we started here as 90. We are currently at 74. What that makes me think is I am happy because you are shedding the dead weight. So for the 70 of you who are left here, I want you to persist on this. I'll be watching. The beauty of it, I will be watching who can be able to access the recording. And for the people who will be able to do this small task, they will have a discounted rate to join the complete intersection design course. This is something that most people have asked me about for quite some time. And this is the advanced program, and it is going to start on 20th. It is 20th, yes. I remember. Let me check just to be sure. No, on 18th. It is going to start on 18th of November, 2024, and it will run all the way to 15th of December. The intersection advanced course will have the following prerequisite. Number one, you must first have completed the road design training with us before, or at least exhibited a proper understanding of design principles. The reason as to why I'm doing that, it is not to deter you from learning. It is because I want this to mentor 20 engineers so that they can have Autodesk certified professional, Autodesk Civil 3D certified professional. That is ACP. So the whole point is I want to get you to the next level of design. Also, I don't want you to come to the intersection design when you don't understand the basics. Ideally, if you cheat to get to the intersection design course, is you're going to struggle and you are not going to get the value for it. So the likes of Vincent, the likes of people who have already done this, and also even if you have not trained with us, but you tend to have a good understanding. And actually, I'm going to set a filtering mechanism when it comes to applications, so that if someone does not understand some concept, they don't proceed to the course. This one, I want it to be a high impact course. I want it to be a highly impact course. People that I'm going to mentor so that they can get Autodesk certified professionals. These ones, I only taking 20 engineers. I am not taking anyone more than 20. Reason being, I will be engaging with you directly. I will be training, reviewing your work, and giving you guidelines on the same. The starting dates, if you're here and you would want to learn intersection design, the starting date is 18th of November 2024. Note it down, and I'm also going to send a reminder. Some of the things that will be covered in this course include: 1, all at grade intersections. We'll also be able to cover grade separated intersections. We'll be talking about speed change lanes, and we'll also be covering signalized intersections. We'll also be covering roundabouts design. We'll be talking about overpasses design, and we'll also be talking design of dual carriageway roads. So this program will be priced at $150, and this is exclusively for people who are committed. It is also a course that will have a pre-qualification for you to join the program. And ideally, the ultimate goal is for you to get an Autodesk certified professional. I already gave you the certificate that you did. Now you will be doing another exam. At the end of the course, you'll be able to do another exam. And I'm also going to set an exam for you. And then after that, you can do the exam with Autodesk, and then you will get your ACP badge like the one that I have. The price for this course will be $150. And this is exclusively for people also who are very committed and they have experience in actual design. I want people who have experience in actual design. I'll be giving out the list of all the prerequisites that you need to have for you to qualify for that course. For the rest of us who would want to advance their normal design skills, and of course I have to give it away to my people who have been with us, the likes of Renee. I can see most of you here, and I've also seen new faces. If you would want to master road design, and this is ideally, I'm not talking about master because I want to use just a fancy name to talk about mastering. It is the actual training of road design to meet industry standards and specifications. It is you comprehending how practical road design is done. How do we do design I have currently been working with Kenya National Highways. I've designed like 7 projects that are already, some have been constructed, others are under construction. So these are real world scenarios on how to design. I can see the likes of Abhishek Kumar, and most of people who have already completed the program. And this is the last cohort that we'll be doing for this year. And I am grateful to God and to most of you that in this year only, we've been able to do 7 cohorts, and this is the 8th cohort, so that we can be able to finish the year. And ideally, this will be running for 5 weeks, and it is going to start on 4th of November. From 4th of November all the way to 6th of December. Yes, if that's right. Nowadays I'm good. Yes, up to 6th of December. So this program will be centered around bridging, mostly for beginners and intermediate engineers. I want to give you what I have been given in the last couple of years. I want to give you my experience. I want to give you my knowledge. I want to equip you with skills that are relevant in the market. And this is the last cohort for the year. And I want it to be unique and personal to me, and also to the people that I'm going to take through this. We'll also be doing 4 softwares for the first time. We already did introduction to Global Mapper, and people now already know to where we are. So I stopped it because now when it goes to analysis, that's where we want to bring the road design now, so that it can join and proceed to that point. So everything is calculated, Melinda. So I want only 100 people to be able to join the current program. It is the last one for this year. The next one will be in February. And for most of you who I'm seeing here, you've been through this program. And if you've not, this is your chance. I want you to learn. I want you to grow. And I was talking today in the morning about being the man in the arena, or will you be able to keep up? There's a lot of transformations and changes that are happening in the construction industry. Everything is shifting. Anyone, and this is the differentiator, anyone can be able to supervise works. Anyone can wear a nice reflector and they go to site, and they will be able to supervise works. Mostly, even most of them think that supervision is just walking around the site with a double cab and a reflector and whatever. But it is only for a small percentage of the ultimate engineers that will secure the future of the industry through design and BIM, building information modeling for infrastructure design. I have not talked about it because my perception of what I want to do with you people, or people who listen and learn from me, is I want to take you through a journey that you will look back to where you came from, to where you will be by the time I finish with you next year. And this is why I've not opened any cohort, a different cohort for any software. And that's why I'm opening down the advanced. Because I want to take you through a journey. And for you to be able to learn BIM and GIS, it will require you to have the fundamentals of the CAD, computer-aided design, and 2D drafting that we are currently doing. It is only this model for the same project road that we normally design that we are going to transition and integrate and move it all the way to 4D, scheduling and planning of this project. So, if you want to secure a share of the future, and I'm seeing, for example, in Saudi Arabia, in Asia, there is extremely rapid adoption and hiring of people who are very good in design. People can be able to integrate BIM for infrastructure, for building design. It is the biggest market, and I'm telling you for a fact. People might be looking to the West and other different countries. Leave those people alone. Those people are at sustainability stages. They did projects during the Industrial Revolution. That's when they were having great breakthroughs. I know, yes, there is construction and developments that are happening, but the bustling continent is Asia. That is where you see Dubai, whatever, Kuwait, those countries. That is where you see the line, NEOM, those projects. I've been tracking them. And I went to their job descriptions of the things. Please go check those things. I want to prepare you for the future. And I am also going to the future. So these programs are not about being fancy, spending time here. It is about you people preparing. And that is what I was talking about today morning. Will you be constantly dedicated to your mission and vision? Will you show up every day? Will you develop the character of an high achiever? If your day you're just getting tired with one day, if you go to NEOM, I was talking to an engineer who is working in NEOM. He was telling me he hits like 17 hours. But here, you cannot manage to come to the webinar after a short day here and there. You need to know how to handle pressure. I've been learning how to handle pressure, and I'll keep. I was talking to another gentleman of mine here, and I was telling him, as your competence grows, as you come to learn with us here, your responsibilities will exponentially grow. And I was also telling Blasius the same thing. The more competent you become, the more will be given to you and assigned to you. So it is up to you to develop the stamina and the capacity and the character of an high achiever. Because if you're growing, if you're learning, if you're advancing, responsibilities will naturally come. And this is why I want you, my beautiful people, focus on developing. If you're yet to join this training program, if you're yet, the design course is going to start on 4th of November. If you are yet to join, I want to send the registration form right now. And I will be texting you tomorrow. And I don't want you to give a lot of things. I want you to tell me what is the specific thing that you would want to learn in this program. Simple, straightforward. And there you go. That is the form. There is a question that is asking you, what is the specific thing that you would want to learn? Don't mention intersection design. Hold on. That will come. Everyone, wait, we'll be able to do R1, R2, R3 in Civil 3D. Don't worry. I'm going to bring part 2 next week, so you don't have to worry. Okay? So, my beautiful people, the future is in BIM. I don't want to tell you this, but I have been pursuing it for the last, I think, almost 6 months. And I've building, getting in communities, connecting, doing courses that will build my capacity. So that also as I come to guide you through that, I am doing it from a point of knowledge. But for you to be able to learn that, you must start here. That's for a fact. So this is why this course on highway design is a fundamental and a backbone for us. If you are yet to do it, apply today. It is only $75. Most people want to get it for free. Anything given for free is always unappreciated. I have done it for a lot of people. I've given them free slots. They never even complete the course and they never even come back to say thank you. So feel the pain of investing in yourself. I invested in myself. I keep investing in myself. You must invest in yourself. And when the sessions are going, I want you to feel the pain of your money. It is only the pain of your money that will push you to do the right thing. Motivation, you don't need motivation. I have motivation. I have what we call inspiration on demand. And I give to you freely every single day. I'll never go uninspired and unmotivated because you are my responsibility. God has given you to me so that I can be able to take care of you and guide you and lead. So why am I not motivated? That even motivates me a lot. So my beautiful people, if you're yet to do the program, do it. If you have already done it, refer your friends. You win when your friends win. I am here because my captains win with me. I teach them things. And my work becomes easier when they know things that I know. So you, with people you are working with your friends and your colleagues, if you refer your friends and they tell me they came from you, I'm going to be giving them a discount of $5. The cost is at $75. They're going to be getting it at $70. And also there is a free course on our website for Civil 3D road reports that helps you in implementation of the project. So this is it. My mission and purpose in this world is to attend to you people, to guide you. I spend my time to research, compile, think, work out, write notes, source for data, just for you. The only thing you can do is work. The only thing that makes my heart move is to see you succeed. When you succeed, I succeed. When you succeed in this course, you refer people. The likes of Daisy and Vincent and Renee, they succeeded, they learned, they refer people to me. They even gave me some company that I should go and do their training. So I am succeeding because they succeeded. This is the interesting part of life. When I succeed, you succeed. When you succeed, as long as we are working as one family and group and community. And this is what RoadSub is doing for our engineering community. All over the world, we grow and learn and grow together. So the link is here. I've already shared it with you people. For those who would want to apply for the program, it is here. So share it with your community and with your peers. There you go. And we shall be able to grow together. ISAT, the course is going to start on 4th. The date is cast on stone. It's going to start on 4th of November 2024. If you want to close the year with a new skill, and then of course in the new year we'll be doing infra works, vehicle tracking, like we'll be moving up, then you will not realize when you find yourself in BIM for infrastructure design. I am promising you, you will not. You will not know it. That is it from me, my beautiful people. Unless someone has something to say, let me hear from you. The mic is open. Thank you. Someone would want to say something? Anything. This is your community. Talk to me.
Engineer James,
Yes, Renee.
how different is this new course from the one we've done? Because I hear you saying you'll be doing 4 softwares. Is it something that we missed out that we might want to catch up on?
It is over for you. This one is integrating GIS. I wanted to introduce an aspect of GIS. That is why I introduced Global Mapper. So GIS is going to help us in how do I call it? In getting more data about the project so that we can be able now to leverage that into the BIM for infrastructure design. But it is something that you can be able to learn freely, so you don't have to rejoin the program. Yeah, I wouldn't want you to rejoin the program.
All right, no, we'll refer.
Yeah.
No, thanks.
Yeah. But I will be, of course, doing a lot of tutorials around the same. Someone asked for the link to our YouTube channel. Let me copy it here. So for you, Renee, what you need to do is you need to join the advanced one for intersections. That is where you've already done a lot with the road design. You're good now.
I see, but I don't know if I'm there yet, you know. But not that I don't trust myself, but there's things that I still, you know when you, like, I attended the second one, so for me that was when I was getting the aha moment. Oh, this is what James meant, so
Okay.
I'm still trying to piece it together, but no, I understand. Just that I was just curious about the 4 softwares, because I think you also, on the second one, we didn't do, like, for instance, we didn't do what's that, a software that you did 2 weeks ago?
The Global Mapper one.
Okay, so on our cohort we didn't do those. So for me, I got really understood now. So things make a little bit of sense the more we do, the more I do this course. But I'm just because remember, I'm still struggling, just finishing the book of drawings. There's just this mishap that Kanza is trying to help me with. So maybe after that, things will be coming together. But I would actually love to join the other one, the intersections. But yeah, I mean, I'll get people, because on what's this, LinkedIn, I get people. I do refer them. I'm not sure if they come to you, because they ask where to do the course. So I do refer.
Okay, Renee. Thank you very much for your kind words. Yeah, I understand that some concepts become you get to understand some concepts after even some time, and I think that's what I've been guessing from most of our participants here. So yeah, it's good to see you actually reflecting on these things. Yeah, it's good. It's good to see. It's good to see that. And yes, Kanza is such a great guy. He is already in our team. I like him. He has a big heart to help other people. So yeah, great. Who is that? I'm seeing someone texting me here. Tongai. Yeah, my guy. Come with us. I'm gonna be here. This is my job, man. This is what I do. This is what I do. For our YouTube channel, it's just Ron's Hub. I've shared a link here, but it's just Ron's Hub. Our name is so unique. So you're gonna just see us. Yeah. Let me
Sorry,
boost
Engineer
around that.
James.
Yes,
I'm not
please.
sure. I'm not sure if it's only me. I'm hearing Karen talking over you. I can't hear you.
Oh, someone is talking.
I'm not sure whether you are playing a video or audio, but something is actually playing over you.
Oh, okay. Sorry. I think it's when I opened YouTube. Is it gone now?
No, not yet.
Who is that? Okay. I don't know what that
It's
could
Karen.
be. But... Okay. Karen, please. Okay, no problem. All right. Okay. Karen, please. I don't know who is there, but that's fine. Okay.
No,
Yeah,
sorry, it
so
was actually the link. Sorry, it was the YouTube link.
yeah.
That's
Okay,
also.
great. All right. Thank you. No worries. So that's it, my beautiful people. I'm going to share this recording with you.